This is a tutorial on pressure and hydraulics. It's the AQA topic P3.2.5, and our main objectives are to define pressure, look at how pressure varies in a liquid, and be able to use a pressure equation to do calculations on a hydraulic system. So the first thing is pressure. Pressure is defined as force per unit area. This is a definition that is worth learning. The unit of pressure is the Newton per metre squared, or because it's quite commonly used, we sometimes shorten that to PA, Pascal. And 1 Pascal is the same as 1 Newton per metre squared. So as an example, 1.5 kPa, 1,500 pascals, changing K into kilos, and that's the same as 1,500 newtons per metre squared. There's obviously an equation to go with this, and for a force F acting evenly and at 90 degrees to a surface area A, pressure P is given by pressure is force over area, which can be shortened to E equal F over A. Standard units are newtons per metre squared for pressure, newtons for force on area, metre squared. Occasionally we might use centimetre squared for area. Don't convert centimetre squared to metre squared. It's not necessary at GCSE, but you also cannot say 1 newton per centimetre squared is a pascal. It's different. So if we're using centimetres squared, keep it as centimetres squared. Right, typical question. I'll pause the video for a second and see if you can solve this. Okay, here's the answer. So we've got pressure is force over area. We change kilonewtons into newtons, so it's 1,500 over 5, 300 pascals. Next question. Slightly harder. It's a descriptive one. When you do a handstand, the pressure is greater on your hands than on your feet when you are standing upright. Okay, explain. Pause the video, give yourself a few seconds to have a think about this. There's about 4 separate points that you need to get. Right, here's the solution. First point. Surface area A of your hands is less than that of your feet. That'll be 1 mark. Second point, the force F on both your hands and feet have the same. Force, in this case, is your weight and doesn't change. Third part, using the formula pressure equals force over area, we see that P depends on 1 divided by A when F is constant. We always have to have something constant when we've got 3 variables, otherwise we can't answer the solutions easily. So F is constant, and we see that the pressure is inversely proportional to the area. Right, what does that mean? Fourth point. As A is smaller with your hands, then the pressure on your hands will be larger. Because dividing by a smaller number gives a larger answer. A smaller number on the bottom part of the equation. In this case, we get a larger pressure. So just a quick summary on this. These are quite tricky questions to answer. You need to explain about the area. You need to explain about the force. You need to link the two together using pressure equals force over area. And then you need to say what that means in the context of your question. Okay, so there'll be 4 points, probably just worth 3 marks, 3 to 4 marks, and that's kind of a grade A answer. If you're struggling with rearranging equations, quick summary on how to use the formula triangle, because as we move into the hydraulics part of the course, it could well be that you'll be asked to work out the force or the area from a given pressure or other variables. So if we know the pressure and the area, and we require the force, then we cover the force up and we find that force equals pressure times area. Okay. If we know the pressure and the force, and we want to find the area, then we cover the area up and we find that area equals force over pressure. And of course, back to our original equation, if we cover P up, we find that pressure is force over area. So using the triangle, you can rearrange it to find any given variable. You should be able to rearrange this without the triangle, but it's quite a useful A memoir. Right, moving on to some more complicated stuff. Hydraulic machines. First thing is, all assume liquids are incompressible. Learn that. What this means is they will transmit any force, or any pressure, from one place to another without a loss of pressure. In a hydraulic system, you have a master piston. That's the one which applies the pressure on a liquid, so that could be your foot on a brake pedal. This pressure is then transmitted without loss to a slave piston, so that would be the piston pressures on the brakes. And we use the equation P equals F over A in both pistons to solve any hydraulics problems. We may have to rearrange it, which is what we'll just have a look at with the formula triangle. Right, so an example, this is sort of a grade A style question, and there's a diagram on the following page. The first part of the question, what property of a liquid enables a hydraulic brake system to work? So pause the video, see if you can answer this. Liquids are virtually incompressible. That's a very important point. Right, the rest of the question is based around this diagram, so make any notes that you think you might need, although you can always review the video to find out any information you want. So question 2, the master piston applies a pressure of 1.5 times 10 to 6 pascals to liquid. Using the diagram, calculate the force on the liquid by the master piston. So notice we're in standard form now, so again you need to be versed with that and how to use your calculators. So the first thing is to get our equation P equals F over A, rearrange it for F. So F equals P times A. Go back and have a look at the formula triangle if you need to. We now put the numbers in the right order, and we find that F equals 1.5 times 10 to the 6 from the question, times 5.6 times 10 to the minus 5, the area from the diagram, and that equals 84 newtons. So that's the force behind the handle. Question 3, what is the force on the slave piston? Again, get our equation, which we've already rearranged from the previous question, F equals P times A, and this time we're working on the slave piston. You have to state whether you're working on the master piston or the slave piston. Sometimes you might write F1P1 times A1 and F2P2 times A2, just to make it clear what you're actually doing. As we're using words, slave piston and master piston, it's quite clear what forces and pressures we're talking about. Right, we've got our force, we've got the same pressure, 1.5 times 10 to the 6, the same pressure on the whole fluid, acting on both pistons. Different area though, 14.4 times 10 to the minus 5, and that gives us a larger answer, 216 newtons. Okay, there is a descriptive way of doing this question, which I feel is slightly harder. And in words, the slave piston has a larger force because the area of the slave piston is larger than that of the master piston. As the pressure in the system is constant, from F equals P times A, we get force is directly proportional to area. So a larger area means a larger force. This is very similar to the question we had at the beginning, except we've rearranged it and we're looking at slightly different variables, but it's the same sort of idea. And final part is another way of answering this particular question based on the areas. The slave piston is 14.4 times 10 to the minus 5 in area. The master piston is 5.6 times 10 to the minus 5 meters squared in area. So if we divide both of those, we find that the slave piston is 2.57 times larger than the master cylinder. So the force applied by the slave is 84 times 2.57 equals 216 newtons. So there's different ways of solving the same equation. It's probably easier to use F equals P times A on both pistons rather than this system, but it works because the pressure is the same throughout the system. Okay, so what I suggest you do is just make sure you're clear about how all of these work and that you can use standard form with calculators and rearrange equations. The final thing really is just a statement of fact. Hydraulic system is a force multiplier. Okay, so that's the end of this tutorial.